deal with some questions which is already asked in your CBSE board. Chapter 3. When electrons drift in a conductor, does it mean that all the free electrons move opposite to the field? 2012. Now you need to know that if an electron is released in an electric field, stationary electron, that starts moving in opposite to the direction of the electric field, as electrons are negatively charged. Here, if there is no electric field, electrons move, and this movement is due to the temperature present in the metal. So as long as there is temperature, and obviously from third law of thermodynamics we know that every metal or every substance must have some energy, and if there is an energy, free electrons must move. They are not stationary, so they move in a random direction. So it is different for a stationary electron and a thermal electrons in a metal or any substance. A stationary electron will definitely move opposite to the direction of the electric field. But thermal electrons, which move randomly, they do not move just opposite to the direction of the electric field. So I will show you some, I will draw the diagram to make it clear. In the absence of electric field, electrons move randomly in this way. But when electric field is applied in this direction, the same electron will move in, I am showing it by dotted line, like this. And this is your drift velocity. So this way electrons does not move, electrons do not move just opposite to the electric field. The drift velocity is superimposed. The drift velocity is superimposed over the random thermal velocities. So this is your answer. Next question is, why manganese is used for making standard resistances? This was asked twice in CBSE, that is in 94 and 95. So you can see here that this question is repeated. That means in 94 and 95, both the year this question was asked. So if you have an idea that questions are not repeated, so your idea is not very much correct. Questions may be repeated. It was asked in 94, it was asked in 95. It's a very important question. Why manganese is used? Why manganese is used for making standard resistances? And your answer is that manganese has two special properties. One, manganese, the temperature coefficient of resistance of manganese is very low. The temperature coefficient of manganese is very low. And second characteristic of manganese is manganese has very high value of resistivity. These two basic property of manganese qualifies manganese for making standard resistances. First, the temperature coefficient of resistance is very low for manganese, and very high resistivity. These two property makes the manganese qualify for making standard resistances. Now again, an important question, state the principle of a potentiometer. Very important question, and this question is also asked twice in your board examination. State the principle of a potentiometer. So potentiometer works on the principle that when a steady current flows through a wire of uniform cross section and composition, the potential drop across any length of the wire is directly proportional to the length. So, principle of potentiometer: when a steady current flows through a conductor having uniform cross sectional area and uniform composition, the potential drop is directly proportional to the length. This is the principle of potentiometer. It's also a very important question, and it was also asked twice in board examination.